Hello everybody and welcome to this tutorial in which we will be dealing with the multi-phase flow and specifically the volume of fluids. In this case we will have an example which is consists of a tank. I draw it like 1 meter and so its height, width, length 1 meter and 1 meter cubed as a whole volume, and it has an inlet which will be water and the other phase which will be oil, and this will be the outlet, the pressure outlet here. So let's get to do this. We go now to mesh, and if you like me to teach you how I draw my sketches, I just you can if you like, you can text me or you can email me or whatever in a comment as you like. So now we will not take so much care in the mesh because what I want to show you is how to set the how to do the settings of the multi-phase flow model. So in the element size, let me choose 30 millimeters. And let me go to quality, allow me to choose high as smoothing. And now I want to name my boundaries. So here I will create a name selection. I will call it water inlet. The other one is the oil inlet. And here it's the pressure outlet. Or we can just call it outlet. It's okay. Now let's update and go to Fluent. So now let's launch ANSYS. Double click on setup. Let's choose double precision. Double precision, for more information if you want, it's used for disparate length scales, such as if you have for example a long pipe with thin radius or very small radius, and and it's also used with high thermal conductivity, or for example if in your mesh you use the high aspect ratio grids, so you should use double precision because single precision may damage accuracy, because this is due to insufficient transfer of boundary information. So it is recommended to use double precision. However, many problems may be okay with the single precision, and I will choose parallel processing options. And this option will split up the mesh and data into multiple sections to different compute processes or nodes, and as the number of nodes increase, the turnaround time for the solution will decrease. I explained this actually in the first video, in the previous videos, and if you want more information you can check them. Now let's wait for the mesh to be imported, and let's start our analysis. Now I will actually stop a little bit here in the multi-phase when we reach. So let's choose transient because it's changing with time, and let's assign gravity to the system minus 9.81 meter per second at the y-axis. So now let's move and let's go to models, and let's double click on multi-phase, and here the multi-phase model dialog box, here is where you set the parameters for your multi-phase flow. In our case it's volume of fluid, and the number of Eulerian phases are actually the number of phases you use. In our case it's 3, because we have actually you saw the inlet, and both inlets are water and oil, but one of them is water, of course, one of them is oil, but the 3 because you cannot have empty control volumes in the volume of fluid case. So in this case, you should have this control volume initially occupied with a material. In this case, it's air. So this is why. Now, what I need to explain to you here is actually here you can use up to 20 phases, and this is allowed from the Fluent manual. Now, regarding the volume fraction parameters, we go here to formulation and we choose explicit. The reason why it's used only for transient solvers, and it's non-iterative and time dependent. And actually it exhibits better numerical accuracy than the implicit formulation, but you should be careful that time step size is limited by a current number, which is here, and it only appears when you choose the explicit. Notice when you choose implicit, it doesn't appear. And what the current number actually is, it's by default, however, it's 0.25, but it describes the measure. It's actually the measure of how much information crosses a computational grid cell in a given time step. Now, what this means is that when you choose, when a flow crosses a cell, how much information did the system detect in this cell? So if you choose, for example, a current number more than 1, it may be not able to, the system may be not able to detect any information of what's happening inside the cell grid at this, because it crosses more than one cell, and it cannot detect in each cell what's happening. So it's by default here 0.25, and it's a good number. So let me return here to the explicit scheme. What it actually does, it calculates flow based upon an appropriate step which is obtained from previous steps. So it's just you can calculate, for example, the new step is calculated only based upon a previous known step. So it does not need to do to solve, for example, for 2 unknown or 3 unknown equations like a matrix. And this is what an implicit scheme does. It solves several equations from a matrix, because it actually implicit means it's that the flow field calculation depends on the current time step only. So it depends on the neighboring cells in order to actually make up your to calculate your results. Now this can be used for the implicit scheme. It can be used for large time steps, and it allows the reduction of CPU time, and it is unconditionally stable. It is always stable, and which is not the case for explicit scheme. In order for explicit scheme to be stable, its condition is to have small time steps, and I will show you the range of the time step you could use in this example. Now, the other thing I wanted to tell you about is the type of interface modeling here. In our case, it's dispersed, and I will choose it now. And what this means, it's in fact, dispersed is used when phases are interpenetrating, which is in our example, which is our case. Now, sharp is used if you want more information. It's used when a distinct interface is present between the phases you chose. In our case, we don't have this, so we stick to dispersed. And you have an expert options in which you choose the subtime step calculation method. What this does is it's now by default hybrid, which is a contribution from the 3 options above, and the 3 options above starting from velocity based, for example, you can it calculates the subtime step by the size of the cell and by the fluid velocity perpendicular to the surface. The next one, the flux based, is it also estimates the cell volume. This time it estimates the cell volume, unlike the estimation of the cell size done by the velocity based. It sums the outgoing fluxes inside the cell. And the flux average is actually the average of the flux based option, and no need to go deep more into this. I'm trying just to stay between practical and theoretical in order for everyone to understand this. Now solve for every iteration, solve VOF for every iteration. It's as it means to solve for every iteration, but in our case I will solve for every time step, so I will not use it. And what I want to tell you more is about the VOF submodels, and we will not choose any of them because the open channel flow is actually used for examples including rivers and dams, and it's not the case here. And the open channel wave BC is actually it actually allows you to simulate the propagation of waves, and this is very useful in marine industry, and it's also not our case. So now coming to coupled level set, the level set, it's actually used, it's suitable for a two-phase flow, which is not our case. We have three phases. And so I think did I miss something? The volume fraction cutoff. The volume fraction cutoff is a value or a limit, let me say, and it specifies this certain value or this certain limit which you provide as a lower cutoff for volume fraction. Therefore, all volume fraction numbers or values in the domain below this value, they will actually be set to 0, and the upper cutoff is calculated as 1 minus this value, and so that all the volume fraction values above the upper cutoff value are set to 1. Now this is the number by default, and we will keep everything. And before we close the multi-phase model window, we should make sure to check the implicit body force, and this is designed for flows with large body forces. However, why did I choose it? I chose it because it improves the solution convergence by accounting for the partial equilibrium of the pressure gradient and body forces in the momentum equations. So let's now click OK and proceed, and let's go to insert our materials in which we will use. So this is the first one is air. It's chosen by default. Now let's go down to water liquid. Okay, and let's keep everything as it is, and click copy, then unclick the water and go up to choose the oil. So now let's see it's actually gas oil, so it's down, gas oil liquid. Okay, copy, and now let's close everything here. So now we go back to multi-phase and we switch to phases, and let's call our phase. Now the primary phase is by default air. Let's name it air because this will actually we are naming them because it will be easier to see the names and the boundary conditions. So the second one, let's say it's the oil, gas oil. Let's just call it oil. It's the secondary phase, and the other secondary phase is the water. So let's just call it water. Now let's proceed, and however, if you're dealing with energy, you can turn on the energy equation. It's also a good choice. And for viscosity, in the viscous model, choose it's typical practice to choose the K epsilon. It's a two equation model, so let's keep on the standard model, and let's click OK. So now let's proceed and choose discrete. No, let's go to boundary conditions now, and let's go to oil inlet and click edit when the phase is selected to mixture. So this is the oil inlet, And now let's give it a value of 0.2 meter per second, and let's go to air. No need to go to air, it's actually by default. Now let's go to oil and edit, and since it's an oil inlet, the volume fraction of oil is 1, so we click OK. And if you want, you can make sure that the volume fraction of water is 0 and click OK. Now the second thing is the water inlet. We will do the same. It's you click edit when the phase is chosen or is selected to water, and you write 1 here for the volume fraction. Make sure oil is 0 volume fraction. OK, and go to mixture and do as we did for the oil inlet. Choose 0.2 for velocity magnitude. OK, now go and double click on methods and choose as instructions from the ANSYS manual. You choose the PISO, P-I-S-O, and this is actually required because according to the manual, for such calculations, the PISO scheme is required for all transient calculations in general. So let's proceed and let's choose in the pressure, let's keep it the Presto. Okay, and it's actually it's body force weighted pressure interpolation. And let's just not do anything here anymore, and let's go to initialize our solution. I will choose hybrid initialization, and after you initialize, what you have to do more is to set your initial conditions. So you go to patch and you go to phase oil, you click on volume fraction, click on tank, and you patch for the value 0, and you do the same for water and you patch for the volume 0. Now you go to run calculations, or before, let's go to calculations activities and increase 1 in order to auto-save every time step. And now you go to run calculations, and as we said, the time step actually should be used here because we are using transient calculations. It needs to be small enough to capture the phenomena of interest, and also it should be large enough to reduce CPU time. So it's recommended that you, in order to capture important flow features, you choose something between 0.001 to 0.01 seconds, and I will choose the largest one. I will choose 0.1, or let me choose 0.05, and let me run it for 500 steps, and I will wait for it alone. But before, let me create a solution animation, and this animation will be a contour, filled and smooth for the phases that we want to track. So it's on all zones, and let's click save. So close, click on contour 1 again, OK, and start your calculations. Actually, I stopped my calculations here in order to tell you something very important that we forgot in the boundary conditions, and it's that when you go to operating conditions, you should set the specified operating density, and this specified operating density should be the operating density should be switched to the lightest particle here in the between the phases you have. So actually it's in our case it's air, and which is the lightest particle, and it's of density 1.225, and it's by default inserted. So now let's go and click OK. And another thing I want to tell you about is in the phase interactions, it's all about the surface tension. So we should click on the surface tension, and we should choose the surface tension coefficients between the interfaces. Now what the surface tension actually describes. It's you know, since a molecule at the interface is exposed to a different environment than inside the material, like the surface of the water is different than the heart inside, or the heart of the material. What I mean is the very deep of the water, deep of the material. It will have a different binding energy, and this is almost something to do with physics. Now let's not go deep into this so much, but I will set between the interfaces here is I will set something level constant, and switch it constant to all, and it's actually for water, and it's for water, the surface temperature, it's something like 0.07286 Newton per meter. So let's get this written here on the water interfaces. 286, okay, and the same is here. And for the oil and air, let's choose something like 0.01, and let's click OK, and I will run the calculations again. So I will initialize, and I will OK, and I will go to insert the initial conditions. So 0 for oil and 0 for water, and now we can run the calculations. Okay guys, so after we finish calculation, now we go to double click here on results. I just opened it here, and we want to track phases to see in this the interval of time how phases are reacting. So what we do is we go to volume rendering to see it in all the volume. So the first thing we go to is the oil volume fraction. Okay, now let's increase the resolution to 60 and apply. And then now you will see here the okay, this is the oil volume fraction. Now we go again to rendering, and what we do is we go to volume rendering 2, and let's choose it also 60, and let's this resolution will make the picture look more dense, and it's more clear. This is why we chose it. Now let's go to the water volume fraction. Okay, this is the second. Let's click apply. Now I will show you the animation from the first. This is not the first actually. Now let's go also to volume rendering 3, and this time it's for air, which is decreasing inside the tank, because oil it's getting, and oil and water are getting are substituting its place. So here we go to air volume fraction. Let's apply, and if you want you can just keep it like this and just generate the animation. Now this is it. Okay, now if we want to generate the animation, let's go to animation. This is actually at current time step 12, so let's go back to time step 0, and I will save this movie on my desktop, and I will show it to you as soon as it finishes. And actually I will make it a little bit well, let's make the resolution of the air a little bit smaller, okay, so that we can just view the phases of the water and oil more clearly. So now I will enable save movie, and I will go to save it on my desktop. So I go to here, and it depends where you want to save it. So I will delete this. Okay, save, and I will click play, and once it's finished I will show it to you. So you can see here the video, but before I play it I want to take your attention to some adjustments I made before running the or before saving the video and playing it. Is that in volume rendering 1 here you can see I didn't make any change actually, but in the color, just waiting for it. In the color you can see that there is a default color map which is rainbow. Now I changed this for volume rendering 2, which has to do with the oil volume fraction. I made it the inverse in order just to make it visible for us to see the difference between the two fluid. Now what you can do is you can go to gray style and you can have it in gray style. So as you see, this is the gray style, is the gray color is the oil, and the blue color is the water. And now you see here the time in which I inserted it here. If you want to insert it, you go to insert time, insert text, and when you insert text, something like this will appear to you. Now you enable the auto annotation and you go to the expression, and you can set whatever kind of time, like time step, current time step, or time t. Now here I set the time t here, and the string text string I wrote time, and it will appear here. So this is everything. Now let's go to the to show you the movie, and this is how it looks. As you see, it's getting filled, the tank is getting filled, and the time is running up. Okay, so this is everything for now. Thank you very much, and see you in the other tutorials.